Okay, project for the day. I'm just starting on another project to restore a Heathkit vintage digital voltmeter, which has problems with its AC conversion or AC to DC conversion circuit. And every time I do something like this, I lament that I don't have a proper AC pad. I don't know, there's other names for these things, and AC test box, various things, but usually it entails a line cord plugged into the AC mains. That'd be 120 volts AC in North America, and some sort of a disconnect switch and a pair of terminals to connect up wires to, and usually some sort of indicator so that you can have a reasonably safe way of connecting up AC power to things under test, and then instead of unplugging the power cord or something, you've got an immediate way to disconnect it. There's a lot of ways of doing this. Some people use an AC outlet strip with a power switch on it and use a short cord from that to their project. I already have the equivalent of that on my workbench. I want to have something I can sit right next to the project. And so to that end, I've rummaged through my junk box and I found an IEC power socket to go with a line cord, a Dpdt toggle switch for interrupting both the hot and the neutral of the power, a neon bulb in a housing rigged to operate off of 120 volts. It has an internal resistor, you can kind of see it there, and a couple of banana jack posts, which are both able to accept banana plugs, but also which has a binding post, and you can stick a wire through there as well. So that'll be the output. I just need to come up with some sort of a housing to hold all this together, and I do want to have the top surface of it, where the switch, the binding post, and the neon light, those all really need to be mounted into sheet metal, so the top is going to be sheet metal. The back panel, where the IEC jack will be, needs to be sheet metal. Well, this actually could be wood, quite possibly. And then probably the bottom needs to be sheet metal too, or removable wood, just so I can get at it for making modifications or doing repairs. And the rest of it can be wood, so I have to pencil up a scheme here. Okay, I've sketched out in some detail my plans for this. I'm trying to keep it small so it's not taking up too much room on the workbench, but yet big enough that it has some physical mass to it, if you will. Because it's going to have a power cord hanging off of it, I don't want it to be sliding around on the table just due to the weight or the tension of the power cord pulling on it. So it has to be reasonably big. I also plan to weight it down. I'm going to chop up some steel angle brackets that I have to make weights for this. So I've taken into account 2 layers on the bottom and 1 layer on each inside of the wooden frame, and that's represented here and here and here. Actually, there's going to be, I only showed 2 layers here, but there's going to be 4 layers. It's just that the bottom 2 layers go the full front to rear distance, and the other one is a little bit shorter. Instead of from here to here, it'll be from here to here, because it doesn't have enough clearance around the IEC power jack otherwise, or power socket. I'm going to have the 2 banana plugs here. This is top view. They're 3/4 inches on centers. That's a standard. The neon light's going to be off on the left, the switch is going to be on the right, and on the front will be a fuse holder that I did not show earlier. I decided that this should have a fuse in it, and it should be readily accessible, and I'll wire it so if the fuse blows, the light won't turn on. And The front and rear will be aluminum, and I have some scraps of 16th inch aluminum laying around that I'll use for that purpose. The front and rear will be this scrap of 1/4 inch craft plywood, and the two sides will be this scrap of 3/4 inch Baltic birch plywood. So 4 sides of the box will be glued plywood. The front and rear, or I should say the two sides will be glued to the front and rear plywood, and then the top and bottom will be the aluminum panels. Those will be attached with screws into the wood, so either one can be removed easily. And I think this will be a pretty good profile. I could have made it a little shorter front to rear, but I thought the form factor should be deeper rather than wider for best appearance and utility. I also have to leave enough room that I'm not cramped too much for the wiring, although that really won't be much of a problem here. There's going to be minimal wiring. I just had to make sure that nothing's getting too close to those steel plates or too close to the aluminum or anything like that, and that I have adequate clearances. So let's get busy cutting the wood. Instead of the steel counterweights or weights, I was going to use this box of lead that I bought somewhere. It's like lead chess pieces. I don't know why somebody would make them out of lead, but somebody did. I got a whole bunch of them for dirt cheap, and I thought someday I'll have some use for that lead. You have to be a little careful with it, of course, but I wasn't too concerned about that. But I never actually have used it for anything, and since I'm going to use the steel weights here, I won't be using the lead after all. Plus, to get it in the form I'd need it, I'd have to melt it, and then you're dealing with a greater safety issue. I don't have any ventilation for it, so no use of the lead. Maybe someday if I have to weight down a body in the East River or something, I'll use it. Okay, that lines up with the pattern. Okay, the front panel with the cutout for the fuse is there. The rear panel with the cutout for the IEC power connector is there. That means I can glue this up now. I'd almost started to glue it up before and then realized what a pain it was going to be to cut these out. I wouldn't be able to use the scroll saw for it anymore if I did it that way. Okay, that's all clamped up now. Okay, my scrap of 16th inch aluminum has been marked for cutting. Now I have to go to the shears. Alright, the aluminum top and bottom panels are done. 4 mounting holes on the bottom plate, and this is the top plate. 4 mounting holes plus 2 holes for the banana jacks, 1 hole for the neon lamp, 1 hole with an anti-rotation fitting hole next to it for the switch, and that should take care of that. And also for anti-rotation purposes, one problem with these banana jack or banana sockets, I guess they're banana jacks, that's the proper word. These are like Radio Shack ones or something that I've had forever in my junk box, and all they have is these 2 flats on them. That's pretty hard to manufacture. You can't just drill a hole and then file the flats on them. You pretty much need a punch to make those. So what I do instead is I drill clearance holes for the threaded part, and then I cut out a piece like this that sits over it, and that provides the flats for the anti-rotation. I just drill a couple of holes, cut out between them, and then file them flat to get the exact clearance I need in the slot. Well, I think this is going to be tomorrow's job. The glue will be set up enough I can sand that, then mount all the parts, and start wiring it up. I was thinking I might want to make some labels for this, but really the purpose of the tool is self-explanatory. I don't really think there's any need to mark things on it. So I'll try it without the labels. If I decide later I am too brain dead to use it, even in spite of its simplicity, then I'll make some labels. Well, I reversed my decision and decided to make clear labels using my Brother P-Touch label printer using their TZ type clear label tape. Okay, there's that for what it's worth. Alright, I've got my piece of angle iron marked up for the total of 8 pieces I'll use as weights. Well, it's not the fastest way I have of cutting these things. I probably could use one of my angle grinders as a handheld chop saw to do this, but I'll use the bandsaw. After just a few minutes of cutting, I've got these cut out. Now the more arduous part of cutting along the angle. I wish I'd had some flat stock. It would have made this a lot easier. Alright, the glue up job is done. And it's all sanded and the corners rounded. And there's a test fit up before I put a little varnish on this. And I've got the varnished item drying in front of my heater fans. They're still coming up to temperature, that's why they're reading only 60 degrees or so on. I just turned them on. So this is only going to get one coat. It just looks better that way, it doesn't really need it otherwise. And I've been gluing up the laminates of steel pieces onto the aluminum base. It's a bit of a trial to keep them from skating around on the epoxy, so I keep adjusting it until the epoxy tacks up enough that they don't move anymore. Okay, the next morning I used my Dremel tool to trim off the excess epoxy, and the bottom weights fit in there perfectly. I'm probably going to use super glue to put in the side weights because I can't tolerate any creepage on their position. Meanwhile, I'm putting together the front panel, and I've just put on the anti-rotation bracket for the binding posts. There's that. Okay, the light and the switch are on. And now the IEC socket and the fuse holder are mounted on the wooden part. And I need to make sure that it still fits. That looks good. Got ample clearance around the terminals here. The fuse holder clears the weights. And the top plate fits on. So good. There were no conflicts there. Okay, the side plates are super glued on using a gel formulation super glue and accelerant. And once again, I'll do a sanity check. Make sure that lines up and that this goes in there. Yep. So now only the wiring remains. Some wiring done. Okay, there's the completed wiring. Because I have to allow for future disassembly for any number of reasons, I've got some loops of wire coming from the parts that are attached to the wood versus the parts that are attached to the metal, so I can have a few inches of play to sort of unravel those if I need to take it apart a bit. That's why there's all those wires coiled up in there. As part of this project, I've made up a pair of 3-foot long male-to-male banana cords, banana plug cords I should say, using nice Pomona test leads with a high strand count and silicone rubber insulation, so they're nice and flexible. And that'll just allow me to connect this up easier to perhaps a meter or something I'm working on, or other things. And here's the final product. Came out looking decent, I think. I put some nice rubber grippy feet on the bottom and a label to remind me if I have to open it up which side is the better side to open up first. So it weighs quite a lot because of those steel plates in there. I think it's resisting moving around even with quite a bit of force applied to it. I pulled an IEC power cord out of my stock of cords. And by the way, I did verify which side is neutral on these and made sure that neutral is neutral. Both hot and neutral are switched here, but ground is connected to the front panel. And there's the power cord plugged in. Yeah, I'm glad I put that steel in there. This is resisting pulling from the cord pretty well. Okay, it's wired up to a digital multimeter. And moment of truth. Make sure I didn't screw up the wiring anywhere. And we've got our expected voltage on the outputs. Easily turned on and off, and I know that both the hot and neutral are interrupted, so it's as if it was unplugged. Right now I have about a 250 milliamp slow blow fuse in here. I can change that out easily to anything that's appropriate for whatever I'm plugging in. But really, I don't plan to run anything off of this that takes much current, so most of the time that low value of fuse will be fairly appropriate, I think.